Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and nature topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Mathematics in 6. The topic of this tutorial is a mixed bag of DP test questions, round 5, question 5. The topic of this discussion is areas and volumes. The question is included in the video. We have been asked to issue a cautionary note. When doing these questions, please use the method I am going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks, even though your method and answer might be right. See the cautionary note at the beginning of the video. On a side note, watch until the end of the video. If you watch the first 5 minutes, you will not gain a fuller understanding of what you need to do. There is no quick fix in mathematics. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Our question states, make a neat sketch of the graph y is equal to 3 sine 2x and show the area bounded by the graph and the lines x equals 0 and x equals pi over 2. The representative strip that you will use in order to calculate the volume generated if the area bounded rotates about the y-axis. Calculate the volume, and also we need to calculate the volume described. Okay, so first things first is we need to draw the graph. So the graph will look something like this. Minus 1, minus 2, minus 3. 1, 2, 3. Okay, now this is 0. Now we're going to go, the graph is going to do something like this. Now, we have to realize that over here, at this 0 point, is pi over 2. Normally, pi over 2 would be at the highest point. But in this particular case, because our y is equal to 3 sine 2x, we've got to multiply pi over 2 by 2. So pi over 2 times 2 is just pi, and sine pi is 0. So what we're basically doing is binding, so we're finding the area of this curve right here. And here's the representative strip. So we're getting the area bounded by this curve right there, which is all good. So, what we need to say is pi times 3 sine squared x all squared dx. Now, 3 squared is 9, and 9 can come out. So we've got 9 pi. So that's sine squared 2x dx. Alright, so now the integral of sine squared ax is in your formula sheet. If you look at your formula sheet very carefully, you will find the integral to this. So, and also our limits are pi over 2 and 0. So we have limits. Pi over 2 and 0. So, we have 9 pi. Now, our integral is sine 4x over 8. Okay, that is our integral. And now, pi over 2 and 0. So, what we are left with pi x over 2 minus sine 4x over 8 minus 0 over 2 minus sine 4 times 0 over 8. Right, so now that where x is, where there's an x, we put pi over 2. Pi over 2, pi over 2. So, what happens now is that this is just pi. So that'll end up being just pi. So 9 pi over pi minus 4 divided by 2 is 2 pi. So it is sine 2 pi over 8. And 2 pi is 0. So sine 2 is 0, so that cancels away. We've got pi times pi, so it's 9 pi squared. So this will equal 9 pi squared. And that is our answer. So we have 9 pi times pi. So then we are left with 9 pi squared. Units cubed. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comment section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.